Okay, so welcome to this webinar. I see attendees dropping in. Perfect. As always, I will give maybe 1 or 2 minutes before we get started. In the meantime, I'm always using this time a little bit maybe to just say, of course, this is not the only webinar. We have a couple of others. I think in August we have 2 more talking about terrain analysis in one, and the other one, let me quickly check, is more about high voltage lines, because we recently launched an update on underground high voltage lines, so something to talk about here as well. So happy for you to sign up and watch them as well. For the ones who already joined, basically the idea of today is really like having a short slideshow, just trying to maybe ease ourselves into the topic, and we mainly focus, of course, on the software. I will demonstrate kind of a workflow from the site to the CAPEX, let's say. So trying to really start early and move through the workflow and then explain how RatedPower, with the help also of Enverus, can really help the users of the tool there in the different stages. There will be a poll in the middle, so I will just ask your opinion on one question later on. And yeah, of course, you can drop the questions in the Q&A already during my talk. Let's say you don't have to wait until the end. You can just drop your questions, your thoughts in there, and happy to answer them at the end. Perfect. I think we waited a little bit. It's of course also recorded. You can always watch it later if you join late. So let's get started. First of all, the title, it says it already, the PV Developer's Guide to Confident Project Decisions from Site to CAPEX. It will be exactly about that. We start early. We try to go through the entire workflow. To myself, I'm Julian, so principal consultant at RatedPower, working with our clients, especially in the German-speaking region, in the Nordics, and also in the UK, helping them out here in their questions, and of course taking part in this entire workflow at every day. So we hear a lot. We learn. I learn a lot. I also give advice. So that's my everyday life. It's great there. And quick index, nothing fancy. Really, we start with the stage of PV development. I just wanted to grasp the idea where we think RatedPower then can help. And this brings us to the second point already. So what is the PV development, and then how we believe RatedPower can help you there. And the third stage, of course, the workflow inside the software. So what are the stages? Basically, I really have a simple timeline here. We start with number 1, early site identification, a feasibility study. We would then move to the second stage already, where we think about a more detailed feasibility study and planning. So we start planning out that site. We have ideas. We bring them on paper or on the software. We then, of course, in another stage, go to more details step by step, where we then have permitting. We need a bit more details, so we move forward always. This means maybe a more sophisticated energy yield result or analysis, a better layout, anything like that. And then at the stage 4, where we might have that financing topic, this is where the planning or development also requires some information, some ideas, some concepts. Well, then the point 5 and 6, I believe, are more the project lifecycle rather than the development stages. So I marked them here in gray. I put also 2 arrows between stage 1 and 2 and 2 and 3. Of course, you can apply this to every stage, I believe. But the idea is, of course, that this is not a linear process. This will always go back and forth. You will always have some last minute changes. This is never, or I guess never, a ideal process where you really move straight forward and there's no changes. Everything is perfect. So this is, of course, also very important to know, because this is where we believe RatedPower can really be beneficial, because these last-minute changes can be done quite easily. Everything is saved. You have a different iteration. So this is, I think, a great focus inside the tool. Now, how has this been done, or is this done in general? I just listed here a few ways to do these different stages, of course, with great tools like GIS tools, Excel, CAD tools. There are many great tools out there. Also, you can add web pages, third parties, that you can externalize some of the work, of course, but it just shows you a little bit that there are many different softwares, different tools, different methods to use. And our goal would be to kind of give this one-stop shop, to just have one tool, let's say, to cover most of these stages. And this brings us directly to the next kind of section where we believe that RatedPower can help you there. First of all, for anyone who hasn't heard about RatedPower so much, why can I even present you this today? It's basically because we started in 2017 and we went through a lot of improvements in the tool, and this is why we can now actually cover this workflow. In 2020, really, we focused on PV preliminary design. We then are now part since 2022 of Enverus. We are now part of the Power and Renewable product, and this helped us to develop more into different sections. So we now have AC and DC coupled BESS since 2023. We improved the interconnection part there as well. And in the last year, we went a bit more closer to more detailed designs by adding the layout editor. This is something where you can change layout parameters in a more detailed way. And we also added the standalone BESS and for the first time also a site prospection, which is called Prism. It's basically a tool from Enverus, and we now expanded more towards Europe. And we started in 2024 with Spain and France. And in 2025, you can see here the expansion move forward to Germany, Italy, and the UK. And here is a slight roadmap outlook, let's say. So the idea here that by the end of the year, we have more advancements on the 3D energy launch, which just gives you or the users a more comprehensive and detailed energy yield analysis. So this is where we come from, and this is why we believe these stages can be supported by RatedPower. And it's the same timeline. It's exactly the same I presented earlier. Now I added a few images on the top just to demonstrate how RatedPower can help. So you can see screenshots from our CAD exports. You can see the reports, the drawings. You can see interface screenshots here. So just many different ways on how we can help you in these different stages. And just to separate it a little bit, the Prism tool, which is that size prospection tool, is at the early stage, of course. So it's a data-driven prospecting tool, while RatedPower would cover, let's say, all the rest, where we have parametrical design. This is how we did it before only. So you could use input parameters to then get your results. But that layout editor is now something else. It's something where you can actually hands-on move elements, move equipment. So you're not only relying on those parameters. So this is the idea. This is the proposal from my side. So now we, of course, have to check how this is looking in action. So we would move, or I would move now to the software, and I will just quickly reshare my screen so you're able to see the tool. So now you should be able to see RatedPower. You basically see, first of all, the interface when you log in to the software itself. And the first focus will be Prism, because if we started the workflow at the beginning, this is where we do the site prospection. And here under apps, you can see it has been integrated to RatedPower. So you can simply click here on that button and it will open that other product. Now, this might be a bit overwhelming now if you look at it. It does look completely different. It's a separate software, let's say. But a quick overview, you can see here in the middle, of course, the map view. You can see on the right and on the bottom, you can see some widgets, as we call it. So you can see some data tables, some graphs here at the bottom, which just show you that analysis I have done in a more graphical way, because maps show a lot, but not everything. And on the left side, you can see kind of the layers I'm using. And I will quickly guide you through what I did, because in a matter of time here, I'm not going to do a full analysis here from start to finish. But what I've done yesterday basically is I started here with an area of interest. I started looking into France and I looked into the substations, and you can see here a 5,000 meter buffer. And this is this white circle I put around the substations here in this region of France. And this buffer is just helping me to identify parcels within that region. Otherwise, I would not know how far my parcels are away. So with this buffer, I could then move to the next stage where I filtered all the parcels here in this region between 15 and 30 hectares. That was just my idea to filter for this size. You can do a complete different approach, of course. And there are a lot of parcels out there in this region. So what I did, I focused on three, which are visible here. So if I zoom in, it probably will refresh a little bit. I focused on these three red parcels here, which are in the range of 15 to 30 hectares. And then in the next stage, this is where I added some of the exclusion layers we integrated into Prism. So France exclusion layers like the transmission line, tower supports, protected areas, water bodies, and routes are now visible as well. So I can see here in yellow, this is a lake, for example. I can see some roads crossing by. I see a transmission line here on the northern part. So with the tool, I was now able to kind of go down from, let's say, I have the whole of France, or maybe let's say I have my area of interest in general, and then I could filter down, okay, where are my substations, where are my parcels, and do I have any effect of any, yeah, exclusion layers? And I picked the ones which are maybe a little bit affected, but not having like a protected area over them. And then, of course, why is this important now to mention? We can use this information now and export it directly to RatedPower. So what I did here on the top right, you can see in my download list is a lot of lists. I downloaded the parcels, the exclusion layers, all of that. And with that file, it's a shapefile or a KML file, I was able to go into RatedPower and move forward with that process of the development. So here I just created a folder. I called it the PV Developer's Guide for today. I will open it and I will start with a new design. So I will start here on the top right, click on new design. This is a common process if you have used the tool before. I just click on PV design. So it will open me the site directly. Of course, in reality, if you do this the first time, this is not the case. So I have already uploaded the shapefile here, or the different shapefiles. So you can see exactly the parcels. You can see, let's say here, the restriction zones, like the lake, for example. However, you see also more than that, because I actually integrated a few more exclusion layers. You can see some of them here in the middle of the area. This is forest areas. I didn't analyze them with Prism earlier, so now I did it in RatedPower. I just manually used here the site feature. I could open here the Prism site I uploaded, and I could edit it, so I can make changes to it. And I just added new exclusion layers to that. And as well, and this is something I used RatedPower for, you have the orange lines here, for example. This is our medium voltage trenches reaching to the substation, which I identified in Prism to be here next to that hydropower plant. All right, so we moved from the site conceptualization and identification to having it inside RatedPower already. Now the question is, okay, how do we get the first layout? And if you have seen other webinars or if you're using the tool, you of course know that there are here all the different parameters we can set. However, we improved that in the beginning of the year by introducing templates, and I will of course use templates here as well to make it quicker and easier to follow. What are the templates? Well, if I click on them, if I open them, basically you see a list. You see a lot of them, and this might already give you an idea of what templates are. I guess it's quite easy to understand. This can be prepared by any team member or by different team members together. You can create a template which should then work as, let's say, the first set of parameters, which is a typical one for France, for example. If I'm here in France, I might have my typical layout parameters for a France design, or it can be for an agri PV design, for example. But what I have done here is I created 3 different ones. I call them all fixed tilt, so I will work with fixed tilt systems here. But I made some notes and I said, okay, here my clearance is 3.5 meters, the tilt is 25 degrees. In another template, I added some local restrictions. And in the further template, it's a bit hard to read because it only mentions the first 2 letters, but we see here ST for string inverters. So the first 2 versions have central inverters, while the third version will use string inverters. And now I'm just clicking on the first one. I will select it. It will also tell me if some of the parameters are not loaded, but this is we can ignore that for now. And then I will match this version with this template with the correct CAPEX sheet as well. So I will move all the way down already. I can do this now because all these parameters in between, they are saved in the template. So I don't have to worry about those. But now I can go here to the CAPEX, and well, I see there is public information, but in order to be a bit more accurate, what I have done is I just wanted to demonstrate how I can also use my private CAPEX sheet. So instead of public, I will move to the private section. And here I just created two for France string inverters and France central inverters. And as I mentioned, the template I'm using is having central inverters. So I'm going to change this. Now it is selected. And now I can run my first version. So with a matter of few clicks and a much fewer clicks than before, I am able to get my first result. While this is fully loading, I can do the exact same step two more times. So I will load the other template, which includes local restrictions. I will double check my CAPEX template, which I don't have to worry about because it's, of course, still central inverters. I'm going to run this. And the last one will be another template, which is the one where I switched technology. So here I saved a template with string inverters. So again, now the importance is, of course, that I would change my CAPEX sheet to include costs for the string inverter. So I will go here, I will move down to string inverter, and I will change this and run. And of course, with a matter of seconds, we have 3 versions created, and we are now at this next stage already. So we are now having a design here. We can see here that we have a layout. Now let's start with the first one we created, which is number 23. You can see here I did some other tests before, of course, but number 23 is the one which we have as a first preliminary layout. Number 24 is the one where I added some local restrictions, and I can definitely see it here. For example, near the forest areas, there is a big, well, more spacing around. This is exactly the local restrictions I have inputted here. And you can also see, by the way, that all these restriction zones are now renamed. I saved this in the template as well, so the software will automatically rename this one to a lake, the other ones to a forest, and this one here in the middle to a pond. And the third one, as we remember, we only switched technology. Well, only. We switched the inverter technology. This means the layout might not be super affected because the DC part is, let's say, kept the same. But of course, in terms of energy yield, in terms of costs, we might see a difference, of course. All right, so these 3 designs are done. Now, I mentioned earlier those errors where we have to go back and forth. So this is not always a linear process of the development. It's not like that I can move now to the next stage, more details, and I'm done. Of course, there can be some last minute changes. What I thought of was a grading analysis. So what can happen is that you might come back a couple of days or weeks or even, of course, a month later, and you might be asked to perform a grading analysis. This is just one example. So what I can do is I can now, of course, create another version of my design, including a grading or topography slope analysis. Again, I will not dive into it in full depth because we just don't have the time for that. But the idea is now just to include a grading analysis in both directions. I will use north-south slopes and also east-west. So I will basically analyze all directions, and I will just define here certain limitations. So 15%, let's say, is my structure installation limit, and I also want to have some earthworks, which should help me flatten out the terrain where it's needed. I will do this here. I will do exactly the same here as well. And then I'm done. Let's activate this here. Perfect. Okay, so what's the idea here? Of course, it's not only that you see analysis now. So when this design is run, I not only want to see where I might need earthworks, I also have the intent to allocate costs to it. I don't want to just see a different layout or changes to that. I also want to see how the costs might change. So of course, I have included in my CAPEX sheets a certain cost for the cut volume and for the fill volume. So per cubic meter, an X amount of money is needed or required to pay to cut and fill terrain. In terms of what the analysis does, simply you see here, it spotted the spots where we have more slopes or steeper slopes than I put it, or I injected here as a parameter. And you can also see the fill and cut volumes in cubic meters. Perfect. This is just one example, just to demonstrate how RatedPower could help you here. If you come back a couple of weeks later and you want to change something, you can do this. And of course, here within those different parameter sections, you have more and more inputs you can choose from. So I will save all these 4 designs now. And now let's move to the next stage. So we have created this, but we are still a bit unaware what might be the optimal design. And here exactly is where I would maybe ask the audience now to quickly answer a poll. I just want to ask you what parameters I should focus on. So basically, I want to compare these designs now, and I want to see what's my most beneficial design. But the question is, would you like to have it in a LCOE focus, energy production focus, total cost, or specific production? I think this is the four parameters I chose. So happy for you to just quickly select which one you want to choose, and I will wait a few seconds, and then I will just make sure I will focus on exactly the one you were preferring. I currently can see a favorite for being LCOE. Perfect. I think the voting is almost done. Great. I think we can leave it here already. We have a winner. It would be LCOE. It was closely followed by total cost. We can of course also look at both, but it was just an idea to get an idea where you would like to focus on. So how would that work in RatedPower? Well, pretty easy. We have created those four designs. Again, we can add some notes here to give more information, but we remember number 23 is central inverters. 24 is also central inverters, but with local restrictions. 25 moved to string inverters, and then 26 is that design including the topography analysis, the grading analysis. So I will compare it now. This is a comparison table in RatedPower. You can add, of course, more entries here. We see a list, but we can expand this list. We can compare also other parameters if we want. As LCOE was winning, I will quickly just sort here by LCOE. Let's move down. So we can see there's not a big difference in LCOE, but we can see that design number 24 is the one having the lowest in this example. The software also highlights this. And to quickly check, we have a central inverter technology, and 24 was the one with local restrictions. Of course, it's not the one with the topography analysis, which is the number 26 here. It is, of course, the most expensive one, as we added this additional costs of grading and cutting and filling. But again, if we would have liked to focus on the total price here, you can see 44.6 million euros as the price for this design. There would be lower ones for our string inverter solutions. Of course, this is far away from saying, okay, this now is the final design, you should go with it, you should build it. No, of course not. It's just a matter to show you that if you have used CAPEX sheets in RatedPower, if you use different versions of designs, you can go here, you can compare them, and you can now already know at this early stage, okay, this might be the one I would like to focus on and continue with. You can do this analysis only also by graphs, of course, and you can export this into an Excel sheet to further work with it if you want. Now, I'm just going to say we're going to leave with 24 as our favorite because we wanted to focus on the LCOE. So I'm going to go one step back and now move to my final part of this presentation, let's say, which will be the furthest detail we can go in RatedPower, which will be that layout editor. So if we assume that number 24 is the one we actually like the most, we can now click on this pencil, and this will open a complete new interface. It doesn't look like RatedPower. It's more that layout editor view now, and it shows you the plant. It will show you already here the different power station DC-AC ratios. I can just don't show them to make it a bit more easy. And if I zoom in here, I see basically, I don't see the cabling currently. I see tables, I see power stations here if I zoom in, and I see the roads. And now the idea is that you as a user can go in here and make some tweaks. You can just say, okay, the algorithm of RatedPower got me close to what I wanted, but maybe not what I wish totally for. So maybe these individual tables here on the north, I want to delete them because they are just never going to be built like this. So I'm going to delete them, for example. Or I remember this was a forest area, so I can also multi-select a couple of structures here, tables, and I can just delete them. So I can multi-select them and I can just delete them as a bunch because I know this area probably will be shaded most of the time because there's a big forest in front of it. So these tweaks to the roads, to the power stations, and to the structures are possible in the layout editor. And this is just, let's say, the further stage we can cover. The question is, of course, why can I not use CAD for that? This is also possible in CAD. Well, the idea is that I can then click this Generate Design button here, and this helps me to not only update my layout, it also helps me to update my documentation, my energy analysis, my bill of quantity. So everything is kind of updated when I click that Generate Design button. So let's see once this is loaded. It's currently validating. And with it, I would say I'm also almost at the end of the workflow in RatedPower. The last thing I didn't mention at all is, of course, the documentation. So the documentation always helps you at every stage, at every step of the game. You can always download the set of documents. It can be financial results, the cash flow results. It can be reports. It can be CAD drawings, all of that. So if you're interested in having a set of documents, just reach out. We can help you out there. Perfect. Now the design is loading, the edited one, and the documents can always be found here under the docs button. Oh no, I generated it twice. But yeah, so this is the whole workflow. Quickly going back to one slide, and then I'm also done with this slideshow. Would be the recap, just quickly recapping what I covered, and then of course I'm open for any questions you have. I hope you can still hear me because my laptop seems to be a bit slow right now. Let me try to reshare the PowerPoint. All right, so you should be able to see in a second the slides. And then the last recap, it's nothing new. It's just basically that what we covered in this whole process, I will use the exact same drawing as before. We started with like identifying parcels. We identified parcels near a substation. We added some local restrictions and got our first layouts. We used Prism and RatedPower for that. And then in the next stages, we, of course, ended up using RatedPower all the way. We changed technologies. We used our templates. We used different CAPEX sheets. And we also applied one example of terrain grading. And then further moving down, we compare designs. I mean, it was a very easy comparison, but you can do this a bit more complex. Of course, if you want to have more designs, you can compare multiple designs at the same time, not only four. We made some changes to the layout, which we call the more advanced changes to our layout, which was never possible before in RatedPower. And then very briefly, I just mentioned the documentation, which is also part of that step 4, the financial reports, which you can get. So this is how I hope I proved that we can actually help you out in all of these 4 stages. And now I'm open for any questions you have. And I think I saw already some in the question box, so that's perfect. And I believe while the questions are coming in, I will quickly switch again to the software because I suppose some of the questions might be better answered in the tool. Okay, first of all, you should be able to see the tool again. And yeah, so I will start from the bottom, from the first one. And let's go to the first. Okay, so we have the one, can you please show the CAPEX template and, no, it's moving around. I have to open it. Can you please show the CAPEX templates and the cost breakdown after simulation so we see the difference between the templates? Yeah, that's a very good point. And I believe I should have shown you this while I was demonstrating it. It would have been clearer in also analyzing or understanding how the comparison works. So when we talk about the CAPEX, let's move right here. I renamed them, and if I show the details for the string inverter, for example, you see a couple of things. First of all, you see that they come from a public source. That's Arena for the PV side, and it's NREL for the US side. And you can see here that there are different inputs. They don't look like the public ones because I changed them. So for example, I allocated a cost to the inverter, to the string inverter here. I changed the currency to euro. The public ones will be in US dollar. And I chose the unit to be the inverter number. And for example, here, if I move a bit more down, I see here also the cut and fill works. I allocated a cost per cubic meter. The public sources we have always come in kilowatt peak. It might be a good first estimation, but I just wanted to demonstrate here that I can use and change this to addressing more specific costs, like more specific earthwork costs, more specific equipment costs as well. And of course, this looks different, a little bit different for our central inverter one. Here, I simply change the price for the inverter. So it should look exactly the same. And well, you can see a rough price here. It's a very straight number, but here I changed the inverter I chose was a central one, and I changed the costs, while all the rest I kept the same, just to have a difference in my results. So this is also where the difference comes from. And of course, if you as a user break down this whole list more, and you can add your own entries, you can modify this completely, you can get a more detailed CAPEX analysis. But I hope the concept was clear. Another question was about the design templates, how it covers local restrictions. Very good point. It might be a bit misleading when I mentioned local restrictions, like, okay, it will always look into where am I, and it will apply certain restrictions. What I was meaning by that is I went here into the layout under setbacks simply, and I went down here where I had my lake and I had the different restriction zones, roads, forest, and the pond, and I added some setbacks to it. So instead of using the default ones from RatedPower, I added those restrictions here. So assuming I needed to keep a distance from 4 meters of the pond to the structure, I added them here. And for the forest, I think here was most clearly visible. I added, for example, 15 meters, while by default, we actually have no setback here. The setback here is always 0 by default for the user to input something. So the local restriction simply was my input here, which I saved for the different restriction zones. Super good question. There was another question. Can you explain a bit about how you integrate BESS into this workflow? Great point. And yeah, I was hoping for a question like this because it was also mentioned, I think, in our introduction of the webinar, and I only covered the PV workflow here. There is two ways of doing this. There is a way when I chose central inverters. Let's double check which design had the central inverters. I think it was design number 26. So if I have central inverters, it's quite, well, it was with string inverters. Let's go to number 23. With central inverters, we can do it directly in this design because we could integrate DC coupled BESS. So I would simply move down here to the BESS section. I would need to enable it. And because I have central inverters, the software will automatically select DC coupled BESS because AC coupled BESS in RatedPower requires a separate area. And to cover it briefly, we do have those power stations here. This is where the central inverters are located. And if you would now run a DC analysis, DC coupled BESS analysis, I can just run an example. It will put BESS containers right next to that central inverter PCS. So let's see, once this is loaded, we will see the result. So this is the one workflow. Of course, this is only related to the layout. What you can add as well is a dispatch strategy. So this is by default disabled because it always requires more computational power. So if you want to enable it, you can enable it. And you can, and this looks the same for DC coupled or AC coupled. You can introduce those parameters where you say the charging efficiencies. You can tell the software, can I charge from the grid or not? State of charges, all of that, the degradation, and then you will be able to run a dispatch. We currently focus on arbitrage and peak shaving, let's say. So these two models are supported, and then you can run an analysis on that. So if I zoom in here, first of all, we see our BESS containers, simple container here, one container next to my red power station. This is due to the requirements I've set here. You can, of course, add more containers to that. And the dispatch, of course, the question for the dispatch is, okay, but how does it do arbitrage or how does it do peak shaving? Well, the peak shaving is easy. We have the PV production, and whenever the PV production, for example, if we have a very high price, we have to purchase energy at a very high price from the grid, for example, we have a very low price in the grid, so we cannot sell it for a high margin. We can use our DC power or the power from the PV side and can charge the batteries directly, or if our inverters are clipped. We might have a very sunny day where we have a lot of DC power and our inverters are overloaded. We can use that excess energy and just put it directly into the BESS. So this is kind of how we can peak shave or utilize that energy. And the arbitrage, where we literally can sell energy to the grid and buy from the grid. This is, of course, highly related to the power prices. So here in the financial part, where we all earlier looked at CAPEX, we have some other inputs here, OPEX and the revenue. And by default, we work on the PPA. So we have a PPA price. But of course, if you have batteries, we can also utilize, or it makes more sense to utilize variable prices here. So by default, for each European country, we should have the day-ahead market price from last year, but you can upload here your own forecasts. Maybe you obtain them from a third party. You can upload here your forecasts for power prices. And the AC coupled BESS would work very similar. I think in terms of time, we don't have enough time to demonstrate that really. I will see how the questions continue. But of course, for the AC coupled BESS, what comes here as an additional part would be the layout. So we improved here a lot on the layout, and I might have an option to show you that in a minute. But I hope the idea of how to integrate BESS is clear as well. And you can always do that afterwards. You can have your existing PV designs and you can add the battery later on. Or of course, you can run a standalone BESS as well. You can ignore the PV side completely. There was another question. Is there a section within CAPEX for grid costs, cable routes, or overhead lines to connect to the network? So that question is also very good. So let me go back to the CAPEX, and apologies for jumping here. But if I show that example, of course, it's important to understand that this is not fixed by us for you. You can change this. So if it mentions here grid connection, this is coming from the public data. So yeah, this number here was a public cost for a grid connection based on kilowatt peak. So the kilowatt peak of DC power was $65.8. You have to say dollars if it's from the public source. I changed it here to euros because I changed some of the prices here to euros. So yeah, you can allocate the grid connection cost for sure, no problem. However, the price itself has to come. It either comes from the public source or from your own research. So it's not that if we put grid connection here that this number here gets always updated. No, it's an input you can set. And in terms of unit, you mentioned double check cable routes. Yes, so you can go into here. You can look for MV, for example. So here we have the different MV cables we use in our trenches. So if you know which trenches or which cables you were using, you can simply choose the one and then allocate a cost because each of those cables might have a different cost. So this is definitely possible. And if I go for HV, let me see if it looks for it. Yeah, okay. That HV overhead line, I think, is not yet represented in our unit list. But if I go to substation, we do have some parts of the grid which is substation related. I earlier saw it. I think it should be at the bottom. Yeah, here, for example, if I have here, these are parts of my overhead line, so of the towers of the overhead line. So I have some length indication here. I can get cost for my towers if it's an overhead line. And I earlier also seem to see here's a pooling substation. So I have substation inputs. I looked for sub earlier, but it actually is ST. So ST is substation in our case. So you can allocate cost for that. So maybe some improvements from our side to do on the overhead line or underground HV line part. But as I mentioned, also it was a recent update, the underground HV line. So once they appear in the CAPEX, you definitely can find a unit here to allocate the cost to that. I hope this answers the question. And let me CAPEX. There was one other one here. How many scenarios as maximum do you recommend us for not delaying too much the comparison calculation? Yeah, I think it's also a very, very good question. The thing is, when I see users doing this, they always do it a bit in steps. So instead of doing the entire comparison at once, they usually do it in a couple of steps. So I see a lot that, for example, the DC-AC ratio could be a first step, or the pitch distance. So you run a different scenarios, let's say with different pitches, and then you do the first comparison. And let's say you compare 5 different designs. Then you get the ideal pitch from there, assuming that maybe the tilt angle is fixed. We have to fix something to do a comparison, of course. Then they would run the next comparison, and they would run maybe different technologies, like different inverters, different modules. Again, they might be compare 3 different modules and 3 different inverter technologies, and then they have another 6 comparisons to do. And then they maybe run, well, actually they have more because they have 5 different, no, they have one final pitch result, then they do 6 different technologies, and then from there they go to the next stage where they maybe apply different costs and see that. So I think in terms of delaying, ideally you would do it also in steps, but we hope that this comparison shouldn't be much of a delay. Let's say maybe you experience it here a little bit that my computer is a bit slow in the connection, but ideally there shouldn't be any problem in just making 24 comparisons if you want. But the idea to be like organized, I think, is the best way to start and compare first one parameter and then always have the same workflow so you can replicate this for each of your projects to be more accurate and also have like this, yeah, this kind of idea behind it so you can compare also between different projects. I hope this answered the delay part a little bit. Thinking about it more, I think the other part which would be ideal is, and I see this as well, to not only use our comparison. So for example, what users do as well, they use this table here, the one I'm showing right now, they export it as Excel. It doesn't look as pretty as here, it's just a simple data table, but they export it and then they do, let's say, those 2 or 3 other comparisons, download export them as well. And then they have, let's say, in Excel, they can just make a nice graph to identify very quickly even out of 100 different designs, the ideal scenario. So this data table can be beneficial for, let's say, yeah, like you said, not hundreds of designs, but maybe 20. But then in Excel, maybe it just makes sense to then in the further step to use our exports and just make that overall graph. Ideally, you can do it in RatedPower, but right now I would say the export button here is helpful. So I did this a lot. So I changed sometimes the pitch distance and the DCAC ratio. I changed it 10 times the pitch and 10 times the DCAC ratio. And then I had like kind of a data table in Excel, which easily showed me, okay, where is the sweet spot for this specific design? Again, I hope the answer was helpful in the sense. There was one more. Do you have any advice for navigating and adapting for the unpredictability of the solar market in the US when performing CAPEX assessments? Yeah, of course. I mean, we do hear that a lot, the uncertainty on, well, different markets, but in the US, for example, I can just say that what we offer, and we saw that earlier in the CAPEX, is that we do have public sources which do get updated every year. Of course, this is on a yearly basis and maybe not enough resolution for you as a user. But what I see as well is you don't have to, you don't have to run only one CAPEX. What you can do is you can just run multiple CAPEX estimations after each other. That could be one kind of process where you then do the comparison afterwards. But you can just do a sensitivity here. I think that could be a recommendation because we really do not update automatically every day, let's say the prices for the US market, for example. So the idea could be here, if I go to change the sheet, here for different countries, we have different public sources, and you can either choose the different ones from different years. I think you can find it here. So you can see US 2019, you can see US 2021. So you can maybe run a design with each of those versions. So you already have 5 different cost estimations based on the different years. Or of course you're more advanced and you go in here and you change the prices. Let's say you just see, okay, what happens if that part of the PV plant is changing its price rapidly. Maybe the grid connection gets just much more higher than expected, or development costs increase a lot. Then what happens? How does it influence my LCOE? So again, I would say the idea here would be to quickly change prices and then see the result and just get a feeling, okay, how much impact does this have? I think that's the only recommendation I can give because unfortunately we don't have like a live price update in our CAPEX. That would be great. Moving further, connecting PV and BESS for major projects to the grid. Yeah, I think that's related to maybe the other question we had before. So yes, in terms of BESS, and maybe I think we reached the end, so it's not possible to show, but on our website you should be able to find a lot of articles on how we connect BESS. So I believe this should be helpful as well. But yeah, there's definitely a way to integrate BESS and connect it to the grid as well. And with that, I would say we leave it here. And thank you so much for attending 45 minutes of your day. I hope it was helpful. And yeah, I would say we see each other in the next webinar, or you can just join my colleagues in August during their webinars. Have a great one. Thank you so much.